Hi, this is the fifth video for chapter 14 of Exponentials on logs. So in the last video, we were using the laws of logs to simplify expressions. So what we're going to do now is extend that to being able to solve equations that involve logarithms. So when I say equations involving logarithms, we're talking about something that looks a bit like that, where the terms of the equation have logs. Now we're going to try, obviously the aim is to work out what x is, but there's going to be two possible situations that we need to try and get to. Either we need to use the laws to get to the point where we have log BAP. So we're going to use the laws to combine the logs so that we end up in that situation, because as soon as we've got to this point, we can go to exponential form and we'll be able to solve the resulting equation. So that's one option. The other option is getting to the point where we're using the laws so that we end up with something that looks like that, where we have log to a base of one thing equal log to a base of another thing. If we can get to this situation, then we can equate the two things that are being logged. If this is true, then A must equal C. So we're looking, when we're solving equations, to try and get to one of these two situations. And I'll show you examples of both. Most of the time, you'll be doing this. So let's look at this first question. Log to base 6 of 4 plus log to base 6 of x equals 2. So we're base 6, so because they're the same, we can use the law to combine them. So law 1, log to base 6 of the products of those two, which is 4x, equals 2. So this is now in log BAP form. So we're going to go into the exponential form. Base 6, 6 to the power 2 equals 4x. And you can see now we've got a very simple little equation that we can solve. Okay, so by combining the logs and getting it into this form, we can get rid of the logs. Let's have a look at another one. So we've got a subtraction, which means we can use law 2. Now there's some brackets here. Now what we can't do is, in inverted commas, expand the brackets. It doesn't work. This is a function and this is being applied to this whole thing. So this is one term. You cannot break this up. So we can use law 2 straight away. We can say that's log to base 4 of x plus 1 over 3. This is now in log BAP form, base, answer, power. So if we go to exponential form, 4 to the power 1 equals x plus 1 over 3, sorry. And then we just need to solve. So if we times by 3, 12 equals x plus 1, and then take the 1 to get 11. Another one. So again, we can use log 2, two separate terms. So log 2, log to base 2 of 2x over 3x minus 4 equals 1. Base, answer, power. So exponential form, 2 to the power 1 equals 2x over 3x minus 4. And now we just need to solve that. So we get the 3x minus 4 off the bottom by multiplying by 3x minus 4. So we've got 2 times 3x minus 4 equals 2x. 6x minus 8 equals 2x. If I add the 8, 6x equals 2x plus 8. Take the 2x, 4x equals 8, which means x must be 2. Couple more. So with this one, we've got an x squared here, a log of an x squared, and a log on this side of the equals. So what I'm going to do, first of all, remember this is the whole thing, log of the whole thing, I'm going to move all of that over to the other side. So I'm going to take off log to base 2 of x plus 3. Oops. Do that. Randomly. Press the button. So minus log to base 2 of x plus 3 equals 2. Okay, so now we can use law 2 to combine that and say that's log to base 2 of x squared over x plus 3 equals 2. So again, log back form. So 2 squared equals x squared over x plus 3. Let's times by x plus 3 to get that off the bottom. That's 4, so we've got 4 lots of x plus 3 equals x squared. Now this is a quadratic, so let's make it look like a normal quadratic. Expand the brackets, and then we're going to just move everything over, take the 4x off, take the 12 off, put it equal to 0, and then we can factorise. So that's going to be x minus 6 and x plus 2. X equals 6 and x equals minus 2. So this time we got two solutions because we ended up with a quadratic, but it was exactly the same approach. Now this one is different. If you look, there are 3 terms, but each of the terms have got a log. So there isn't one that's just a number, they are all logged. So this is one of the other ones where we're going to end up with a log equal to a log. So I'm just going to leave that where it is. These are all log to base 10. They're all the same log, same base. So first of all, just need to deal with that 2. So remember, we can't use law 1 if there's a number in front. So using law 3, I'm going to just raise that as an index. Now we can use law 1 and say that's log to base 10 of 2x squared equals log to base 10 of 4x plus 6. And now we've got a log equal a log. So this must equal this. So I'm going to get rid of those logs and I'm just going to equate the two things that are being logged. That must be true. If that equals that, if that's true, then that must be true. Okay, so again, we've got a quadratic. If I move the 4x and the 6 over, they're all multiples of 2, so let's just make it a little bit nicer and easier to factorise. So x minus 3 and x plus 1 in brackets. So that's going to give solutions x equals 3 and x equals minus 1. Okay, the last example, this is more of an exam question where they are going to get you to do something first, and then it says hence, which means see the link between this and this. Okay, so part A, simplifying algebraic fractions. So factorize first. 3 and 1, plus and plus, over x, x plus 1. They cancel, and we're left with x plus 3 over x. So then it says, hence, so using what we've just done. So if you look at this, we've got log of all of that minus log of all of that. Two terms, same base with a minus, which means we can use log 2 to say it's x squared plus 4x plus 3 over x squared plus x equals 4. Now here's the link. That was the algebraic fraction given in part A. So we now know that that simplifies to x plus 3 over x. So that's the hence part, using what we've just done in part A. This is now in log BAP form. So 2 to the power 4 equals x plus 3 over x. Okay, if we times by x, I'm just going to come up here because I've run out of room. This is 16, so 16x equals x plus 3. 15x equals 3, which means x equals 3/15, which is 1/5. And that's the answer. Okay, so they will tie in other topics. So you just need to have a little think about what you're doing, and especially if you see that word hence, make sure you think about what you've just done. Okay, so you should have enough information now to have a go at exercise 14E.